Okay, welcome back to this next video on oocyte activation. Okay, so we've discussed how when a sperm cell touches the membrane of an oocyte, it triggers a calcium wave to spread across the cytoplasm of the oocyte from the point where the sperm cell touches that oocyte. Now what we're going to do is look at the mechanisms underlying this. Okay, so we've discussed how what is believed to happen is that the sperm transfers in a phospholipase C enzyme, specifically phospholipase C of the zeta type. And this phospholipase C zeta then starts converting PIP2, phosphatidylinositol 4,5-bisphosphate, which is a component of the usual phospholipid bilayer, and it breaks it down into IP3 and diacylglyceride. Okay, so IP3 now goes into the cytoplasm. So overall, this has resulted in an increase in IP3 in the cytoplasm of the oocyte. Okay, so now let's draw the endoplasmic reticulum. So let's have a big endoplasmic reticulum here. Okay, so this is the endoplasmic reticulum, like so. Okay, right, and I need to tell you something now, because the important thing to understand is the endoplasmic reticulum is going to spread. It's a big structure, basically. It covers the entire of this oocyte. You're going to have some endoplasmic reticulum going throughout the entire area of the oocyte. So you need to understand that concept, that the endoplasmic reticulum is a big structure and can span the oocyte. Okay, now, in the endoplasmic reticulum membrane, what we know is that there are IP3 receptors. So let me draw a big old IP3 receptor here. Okay, so here's an IP3 receptor, and IP3 receptors consist of four big subunits. Now, we know that there are 4 genes coding for IP3 receptor subunits, and IP3 receptors can form homotetramers or heterotetramers, which means you can either make an IP3 receptor out of 4 subunits, 4 polypeptides, which are all encoded by the same gene, or you can mix and match. Basically, you can use one of the genes to encode for some of the subunits and another to encode for the others. So you can make heterotetramers or homotetramers, basically. So this is an IP3 receptor. Now, basically, before IP3 binds to each one of these subunits of the IP3 receptor, what IP3 receptors have available is an inhibitory calcium binding site. So if I draw the top surface of this IP3 receptor here so that we can discuss this in more detail. Right, okay, so as I say, there are 4 subunits here, 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 and here. Right, and basically, before IP3 binds, what you have available is what I will call an inhibitory calcium binding site. So I'll draw it in red to denote inhibitory. So basically, if calcium binds in this binding site now, it promotes the IP3 receptor being in the closed state. Okay, so this is a calcium inhibitory binding site, or an inhibitory calcium binding site. Inhibitory calcium binding site. Okay, now, when IP3 binds to the IP3 receptor, an IP3 molecule needs to bind to each of the 4 subunits of the IP3 receptor. So let's say IP3 binds here, and I'll draw it. Watch, I'll just draw a circle for let's say this is the IP3 binding domain. Okay, so if IP3 goes up in the neighborhood of this IP3 receptor because this phospholipase C zeta is synthesizing IP3, then IP3 is going to bind to each one of these IP3 binding sites. You're going to get an IP3 molecule binding here, an IP3 molecule binding here, IP3 there, and IP3 there. So overall, 4 IP3s bind to the IP3 receptor, but 1 to each subunit. Okay. Now, when IP3 binds, what happens is that the conformation of the subunit, the polypeptide, changes conformation so that this inhibitory calcium binding site becomes unavailable, and instead it's replaced by an excitatory or a stimulatory calcium binding site. So let me show this here. So what's going to happen is that now you lose that inhibitory calcium binding site, that becomes unavailable, and you gain a new calcium binding site which is stimulatory. So I'll colour this in green. Okay, so the IP3 binding to its IP3 binding site has made available a stimulatory calcium binding site and has removed an inhibitory calcium binding site. So what now has to happen is that some calcium has to come and bind to these 4 stimulatory calcium binding sites, and let me just annotate that. These are stimulatory calcium binding sites. Stimulatory calcium binding sites. So okay, so a calcium ion needs to come and bind to each of the 4 calcium binding sites. You need 4 calciums overall to come and bind to this IP3 receptor. And when they do, they will stimulate the IP3 receptor to open. So the IP3 receptor will then open. Now, basically, in this great big endoplasmic reticulum, you have a huge number of IP3 receptors. Now, let's say they are all occupied by the IP3, okay? So they've all got IP3 bound to them now because the IP3 is being produced by the phospholipase C zeta. And yes, so the phospholipase C is being produced by the phospholipase C zeta. Okay, and so they've all along the cell, basically you've got IP3 being bound to these IP3 receptors. So all the IP3 receptors are primed and ready, basically. So they've all got these stimulatory calcium binding sites available. Okay, now all we need to happen is calcium to go up. So what's believed to happen is a little bit of calcium comes in at the site where the sperm actually touched the oocyte cell membrane. So where the sperm touches the oocyte membrane, what's believed to happen is a tiny little influx of calcium comes in from the sperm, okay? Well, not from the sperm, from the extracellular fluid. And basically that's going to trigger off the entire calcium wave. Because what's going to happen now is that calcium is going to come in. It's going to activate this IP3 receptor that is close to where the sperm is touching. So let's say the sperm's here, let's say. Okay, so there's the sperm. Let me just give it a tail. There we go. So where the sperm is touching, the calcium's going to come in. That is going to activate this first IP3 receptor that is close to where the sperm touched. Okay, so that's going to cause that IP3 receptor now, which was primed because it's got IP3 bound to all its IP3 binding sites. So it's got available these stimulatory calcium binding sites. Now what's going to happen is that IP3 receptor is going to open. That will allow calcium to leave that IP3 receptor. So it will go from the endoplasmic reticulum here, and it will go into the cytoplasm. So you're releasing calcium into the cytoplasm. Okay, now what's going to happen basically is that you're going to get a chain reaction because this calcium is going to go and stimulate the next one along. And we'll continue this discussion in a